Hello, this is the first online lecture in ECON120 Principles of Economics. I decided that since it has been more than 2 weeks since our last meeting, I will go a little back and start from the very beginning of chapter 5 and talk about the behavior of consumers first, and then we'll just go on at hopefully the normal pace. So please let me know if you have any feedback about the lectures and how I can improve those. I'm just learning my ways around so I can become better with your help. Okay, so let's go. I'm going to talk about the behavior of consumers today, and this lecture will match the readings in chapters 5.1 and 5.2 in the textbook. So please read those, see if I've missed any points, and send me your questions. I would really appreciate those. We're going to look at 3 questions today. How should a rational consumer make decisions? I talked about that on the last Friday class before the spring break, which was millions of years ago. Then, how can the individual demand be derived from consumer decisions? I talked about that as well. And finally, we're going to talk about something new. What are the income and substitution effects? So let's take it one question at a time. How should a rational consumer make decisions? When I introduced this topic, I mentioned that we need to define 2 components of choice. We need to describe what a consumer preferences are, that is, what he or she likes and dislikes. And then we need to talk about what the opportunities are, what the consumer is capable of buying. The preferences in our framework will be described by a utility function. So that means that we're gonna assign a number to any alternative that consumer is facing, and the higher the number, the more the consumer likes a particular alternative. And the opportunities will be described by a budget set. That is, we're just gonna graphically or numerically describe what the consumer is capable of buying given the amount of money and the prices that they're facing, the amount of money that the consumer has and the prices that he or she is facing. And the optimal choice in this framework is to buy the best feasible alternative. So pick the consumption bundle with the highest utility within your budget set. And so I'm going to walk you through an example that I used in the previous class. And we're going to focus on a story in which there will be only 2 consumption goods possible, movies and books. And so in that story, a set of alternatives that the consumer is facing would consist of all possible consumption bundles. That is, we need to say how many movies and how many books there will be in a bundle, for example, 3 and 4 or 1 and 5 and so on. And so for each consumption bundle, we will assign a utility number, with the higher utility number standing for a higher preference. So if the first bundle has a utility of 25 and the second bundle has a utility of 10, that means that the consumer likes the first bundle better than the second. On top of that, we're going to follow 2 additional rules. We're going to say that more is always better. So a consumption bundle with more of at least one good is always going to be preferred to the other bundle. And then marginal utility has to decrease. That means every additional movie or every additional book the consumer gets to consume will increase the consumer's utility by a smaller and smaller amount. First book is really valuable, but second book is not as valuable as the first one. Third book is not as valuable as the second one, and so on. That means that we have decreasing marginal utilities. If that is the case, then we can think about all the consumption bundles being placed on a plane, with movies being on the horizontal axis, books being on the vertical axis, and for every bundle that has an integer number of movies and books, we can assign a utility function. So here's an example of such assignment. You can see movies are on the bottom, books are on the vertical axis, and then for, say, 4 movies and 1 book, we assign utility to be equal to 42. For 3 movies and 4 books, the utility equals 50, and so on and so forth. So given the rules that I just described, more is always better, marginal utility has to decrease, the numbers have to start very low in the origin, and I usually start from 0 because it makes most sense. They have to increase going up, so any line you pick going up, the numbers have to increase. They also have to increase going to the right. As you increase the consumption of movies for a fixed number of books, the utility number has to go up as well. That means more is always better. Decrease in marginal utility means that the numbers will be increasing fast and first, but then they're going to slow down. So for example, the first movie contributes 10 units in marginal utility, the second movie only 9, the third only 8, the fourth 7, and so on and so forth. Even if I jump between 3 and 4 movies when the number of books is 4, the marginal contribution of the fourth movie is 7 units of utility. The marginal contribution of the fifth movie will be only 6 units of utility. So it's going to work all the time. The smaller the number of movies, the more valuable the next movie will be. So that is how we describe preferences. Every possible bundle assigns some number. You can imagine how it would look like when we can have any, not just an integer number of any good. For example, if we were able to buy 2.5 movies and 1.5 books, we'll be somewhere here. There will be a reasonable consumption bundle, and we can still assign some kind of utility to that bundle as well. But here we're gonna simplify things by looking at just the discrete world. Now that we've described the preferences, we need to talk about the opportunities. What is feasible? So imagine this situation. You have $24 and a single movie costs $3 and a book costs $4, and you have to basically spend all your money on these two. In the story that we're looking at right now, holding money doesn't give you any value. So basically, you want to spend the whole endowment of $24 on these two things. To draw the set of opportunities, you need to figure out which bundles you can and you can't buy. And the easiest way to do so is to first look at the case when you're going to be only buying one good and not the other. So here on the vertical axis, I'm marking 0.6. If you only buy books, the maximum number of books you can buy is 24 divided by 4, 6 books. If you're only buying movies, on the other hand, the maximum number of movies you can buy is 8. So these are the boundaries of your budget set. Now, if you connect them with a straight line, you'll get what's called the budget line, the set of all bundles that cost exactly $24. There aren't many of them, as you can see. In fact, the only other integer bundle is 4 movies and 3 books, and it costs exactly $24. But the budget line basically describes you all possible combinations of X and Y that cost exactly 24. So anything above the budget line will be infeasible because it's going to cost more than $24. Any bundle exactly on the budget line will cost exactly $24, and any bundle under the budget line will cost less than 24. In fact, we can mark all the bundles under the budget line as affordable because they cost less than the amount of money that we have. And thus we can shift between the budget line, as in just a straight line on the graph, and the triangle which represents the budget set, all feasible bundles available given the price and the income. Now, what is the optimal bundle here? Using the decision rule that I proposed, we should choose the bundle with the highest utility within the budget set. And this is the bundle with utility 54, because you can see, well, you get 52 if you are only buying movies, 53 if you bought 4 movies and 3 books, and 54 if you bought 5 movies and 2 books. Because I'm looking at the discrete case, 54 is not exactly on the budget line. We're spending not exactly the whole $24, but if you were to throw in more math, you will see how things will change by looking at the continuous case. So for now, just convince yourself that 5 movies and 2 books will cost almost $24, so we're almost on the budget line. And clearly we're maximizing utility among the all possible bundles that we can buy. So this is how your optimal choice looks like in this example. Summarizing the answer to the first question, choose the best alternative from the set of all the available alternatives. Carve out your budget set and then circle the alternative that gives you the highest utility within the budget set. This is what we've just done. This is how a rational consumer should make decisions. The second set, how can we derive individual demands from consumer decisions? Well, the idea here is very simple. We're gonna look at the consumer decision and see how that decision changes when the price of a particular good changes. So for instance, if we want to derive the demand for movies, we're going to keep income the same. I'm going to have it fixed at 24. We're going to keep the price of the book at 4, and we're going to fluctuate the price of a movie. For instance, let's increase it from $3 to $4. Increase the movie price to $4. What is going to happen here? What is going to happen to the consumer choice? Well, first of all, we can't buy 5 movies and 2 books anymore. That's too expensive given the new price will go over our income. So we need to adjust the budget line and the budget set to the new price. How do we do that? Well, first thing to notice is that when the price of movies increases but the price of books stays the same, we're still able to buy the same number of books, up to 6 books. But now with the price 4 of movies, we're only able to buy 24 divided by 4, 6 movies. So the budget constraint, the budget line, will move inwards, reflecting the fact that we are now able to purchase fewer movies than before. And so the budget set will shrink, and the new budget set is this darker blue compared to the light blue of the original one. But now we have to perform the same operation. We have the new budget set, and within this new budget set, we need to pick a new bundle that gives you the highest utility. Remember that this utility 54, you can't buy it any longer. So that bundle is going to be a bundle with 4 movies and 2 books. And in fact, if you look carefully, a bundle with 5 movies and 1 book gives you the same utility, but it's going to be more convenient for me to pick this one, 4 and 2. So new highest utility attainable is 48, and you can attain it by buying 4 movies and 2 books. So what about the demand? We have the demand function as the function of the number of movies that the consumer will buy as, sorry, I'm going ahead here. We have the demand function as a function of number representing the number of movies one can buy as the function of price of movies, price of books, income, and all other things. And so the idea for the demand function is keep everything but the movie price fixed. So price of books the same, income the same, other things like preferences the same. Change the price of movies and plot the optimal number of movies that one can buy. So going back to the original story, when the price of movies is $3 per movie, the consumer finds it optimal to buy 5. So plot that. With $3 per movie, buy 5 movies. Change the price to 4, budget line shifts, optimal bundle shifts, and the new optimal number of movies is just 4. Plot that as well. So 4 movies at the price of 4, and repeat this operation for every possible price and connect the dots. You'll get the demand curve. So the idea here is that the demand represents the relationship between movies and its price or their price, once price of books, income, and all other things are kept the same. If you were to fluctuate if you were to change price of books or income, or if you were to change preferences, it will adjust something in our original story. For instance, with the different price of books, the upper corner of the budget set will be in some different place, and so your optimal choice would change because of that. With a different income, you might, with a higher income, for example, you will shift out and you will be able to attain higher utility. So the optimal bundle might change as well. But for a fixed set of other factors, the demand line simply represents how the consumer's response in terms of the number of movies will change to given a change in prices. That's how you derive demand. Now, we can answer the second question. The individual demand is derived from consumer decisions by plotting the amount of a good in the optimal bundle for every price. So find the optimal bundle, plot the number of movies given the price of movie, set the new price of movies, plot the new optimal number of movies, and go on. The last question for today. What are the income and substitution effects? To do so, we need to distinguish, to answer that question, we need to distinguish between nominal and real income. And the distinction is as follows. Nominal income is simply the amount of money that the consumer has. So $24 in our example. Real income is the consumer's purchasing power. And clearly, when nominal income changes, for example, when the amount of money that you have increases from 24 to say $35, your real income goes up as well. You can buy more movies and you can buy more goods for the unchanged, prices of goods and movies. But there could be situations in which your real income will be affected, but your nominal income will stay the same. And a situation like that occurs, for example, when the price of a good changes. Let me show you the example that I'm talking about. When the price of movies increases from $3 to $4, your budget set shrinks. You were able to obtain utility of 54, but now the highest utility that you can get is only 48. So in terms of your purchasing power, the light blue area, the difference between the two budget sets, is the set of all bundles that used to be feasible when price was 3, but it's not feasible now. So when the price of movies increases, your real income falls. And so if that is the case, then the total reduction in consumption of movies by 1, as you move from utility of 54 to utility of 48, occurs for 2 reasons. For once, movies become relatively more expensive than books. The second reason is consumers' real income falls. So you can't buy some bundles that you would like to. And so we will try to split that reduction in consumption, a decrease by 1 unit, into 2 effects. Substitution effect simply says that, well, you should be consuming more because movies are relatively more expensive. The income effect simply says that you should be consuming more or less depending on whether movies are a normal or an inferior good. In this respect, the substitution effect is always negative. If something becomes relatively more expensive, if movies become relatively more expensive than books, you should be buying less movies and more books. In terms of income, there is no restriction. The income effect can be positive or negative because if your real income falls, you would want to buy more of an inferior good, but less of a normal good. So if movies are a normal good, fall in real income means an additional reduction in consumption of movies. But what we're trying to do here is we're trying to separate the 2 reasons because of which your consumption of movies falls when the price of movies increases. Okay, I think that's about it for today.